Steel versus aluminum in structural applications, a structural showdown. Welcome to Blueprint to Reality, your go-to channel for civil and structural engineering insights. If you love exploring how engineering shapes our world, make sure to subscribe and hit the bell icon for more content. When it comes to construction and structural applications, steel and aluminum are two of the most commonly used metals. While both offer impressive strength, durability, and versatility, they differ significantly in terms of weight, corrosion resistance, cost, and application. So, which material is the better choice for your project? Let's dive into a detailed comparison. Understanding steel in structural applications. Steel is an alloy made primarily of iron and carbon, with small amounts of other elements to enhance its properties. It is exceptionally strong, durable, and cost-effective, making it a staple in structural engineering. One of the biggest advantages of steel is its high strength-to-cost ratio. It can support heavy loads and withstand extreme forces, making it ideal for skyscrapers, bridges, industrial buildings, and infrastructure projects. Steel is also highly customizable. It can be welded, bolted, or shaped into various forms, providing flexibility in design. However, steel has its drawbacks. It is heavier than aluminum, which can increase foundation loads and transportation costs. Additionally, steel is prone to corrosion, especially in humid or marine environments, requiring protective coatings or stainless steel variants to prevent rusting. Despite this, steel remains a top choice for load-bearing structures due to its high tensile strength, affordability, and widespread availability. Understanding aluminum in structural applications. Aluminum is a lightweight metal known for its natural corrosion resistance, high strength-to-weight ratio, and ease of fabrication. Unlike steel, aluminum forms a protective oxide layer when exposed to air, making it naturally resistant to rust and eliminating the need for additional coatings. One of aluminum's greatest strengths is its lightweight nature. It is about one-third the weight of steel, making it an excellent choice for structures where weight reduction is a priority, such as aircraft, high-rise facades, and modular constructions. Additionally, aluminum is highly malleable, allowing engineers to design complex and intricate structures with ease. However, aluminum has its limitations. It is more expensive than steel, making it less cost-effective for large-scale structural applications. While aluminum has good strength, it cannot match the load-bearing capacity of steel, which limits its use in high-stress structures like skyscrapers or heavy bridges. Aluminum is also more challenging to weld, requiring specialized techniques compared to steel. Key differences and applications. Steel is stronger and cheaper, making it ideal for large structures, such as buildings, bridges, and industrial frameworks. However, it is heavier and prone to corrosion, which requires maintenance. Aluminum, on the other hand, is lightweight and corrosion-resistant, making it perfect for marine structures, aerospace applications, lightweight bridges, and curtain walls in skyscrapers. However, its higher cost and lower strength make it less suitable for high-load structures. Which one should engineers choose? The choice between steel and aluminum depends on the project's specific needs. If strength, cost-effectiveness, and load-bearing capacity are the priorities, steel is the better choice. However, if lightweight design, corrosion resistance, and ease of shaping are more important, aluminum is the way to go. Conclusion: both steel and aluminum have their place in structural engineering. Steel dominates in heavy-duty structures like buildings and bridges, while aluminum excels in lightweight and corrosion-resistant applications like aerospace, modular construction, and marine environments. Engineers must carefully weigh factors such as strength, weight, cost, and environmental exposure when selecting the best material. Want to learn more about engineering materials? Subscribe to Blueprint to Reality for in-depth structural insights. Don't forget to like, comment, and share this video to help more people explore the world of structural engineering. See you in the next one.